Good morning to everyone. Okay, before asking question, Saksham has given my AVs okay. Thank you, Saksham. Okay, let us start today's class. So, in the last class, that is yesterday's class, so we have studied about optimal generation scheduling considering transmission losses. So, when we have to consider transmission losses, when the plants are situated or located at different locations. Understood? So that time we have to consider. So therefore, what we have to do now, we are going to consider this one extension of yesterday's class. Let us see here. So people are still coming in. Admitting them will take time. Like regular class also they will be coming, and online also they keep on coming. Okay, fine. Now all these things till this point we have studied yesterday, and we have derived the equation 9, isn't it? So this is exact coordinate. So that's what I'm telling it. If the plants are located at different locations, then you have to consider transmission losses. And if the units are situated in the same plant, then it becomes a local load. So then only you have to consider economic dispatch. So transmission losses, you have to neglect it. So because in any competitive exams, they will be asking this one. When you are going to consider the transmission loss, when you are not going to consider the transmission loss. So this is the answer. When the units are situated at same plant, then you have to neglect the transmission losses. So because you will be dealing it with only economic dispatch of the generators which are situated near the same plant, like Rajchur thermal power station. I said example, 8 units are there in RTPS. Okay. Then if they are situated at different locations, then you have to consider the transmission losses, isn't it? So like I said, one RTPS is there, thermal station, then in Ballari it is there, then Jindal is there. So like that, any thermal stations are located at different locations, then they have to, whatever the power they are producing, they have to transmit over a transmission line. So obviously losses will occur on the transmission lines. So in such case, we have to consider the transmission losses. So based on this one, we have derived this equation 9, which is known as exact coordination equation. So that's what yesterday I was telling. Most of the students, they will commit a mistake in test and examination whenever this question is asked. Derive the exact or obtain the exact coordination equation. That means exact coordination equation you are going to get when you consider the transmission losses. That is equation 9. Understood? So when you don't consider this one, transmission losses, then you know that incremental fuel cost all the plants are equal. But here you see the incremental fuel costs, you can see that equation will be different here. Understood? So that means what? Incremental fuel cost is multiplied with a penalty factor will be same for all plants in this case. So this is what we have to derive it. Till this point we have studied yesterday. Now let us continue this one in order to obtain the further expressions of this one. So till this point. So now it is clear that to solve optimum generation scheduling problem, it is necessary to compute ITL. What is ITL? Incremental transmission loss, isn't it? So therefore, if you want optimal generation schedule, so this is the optimal generation scheduling. So you have to find out ITL. What is ITL is replaced with your dou PL by dou PGI, isn't it? So this is the thing you have to find out, incremental transmission loss. Now how to find out this incremental transmission loss? This we are going to study in today's class. How to find out this ITL, where ITL is equal to dou PL by dou PGI is replaced with your ITL, isn't it? That's what we have seen it here. Okay. So that we are going to study. Incremental transmission loss, we are going to see that one. So one of the most important and simple, and we are not going to get a exact method of expressing transmission loss. There are so many methods are available. However, that is not there in the syllabus. But a simple and approximate method we are going to consider here to derive the formula for transmission loss. So what is that simple and approximate? This expressing this transmission loss as a function of generator powers through B coefficients. This you know that the transmission loss, that is PL, transmission loss is denoted by PL, isn't it, in our expression, is a function of your active power generation, isn't it? PL of PG1, PG2, I have seen it. So I have explained it, isn't it? It's a function of active power generators. So how to express this transmission loss as a function of active power generation is through B coefficients. This is the one approximate, but it is a simple method we are going to consider here. Clear? So through B coefficients we are going to consider, that is this one. You can see this one, this B coefficients we are going to consider. Okay. So what is this B coefficients? How to get this B coefficients? So let us see this one. So first one is the general form of loss formula using B coefficients is represented in different forms. Understood? So the general form for loss formula, that is PL, using B coefficients is represented in different ways. Either it may be represented in index form or matrix form or any other form. So first, well, let us take when this is represented in index form. Index form means what? You know index, I, J, etc., K, etc. You will be putting it. So if it is expressed in index form, this is how the PL is represented. So what is this PL? Is the transmission loss is equal to the product of, you can see PGM, BMN and PGL. So this is what, how it is represented. That's what I said. It is a simple but approximate formula we are going to derive. So as a first step of these proceedings, so you have to express that one in a index form. So why it is called as index form? I think it got stuck. Okay. So you see there are two indexes are there, M and N, varied from 1 to K. Understood? So therefore here PG means generation at M bus and N bus, and in between we will have a B coefficients between M and N, that is BMN. Understood? So this is the PGM means it is the reactive power generation at mth plant, and PGN is the active power generation at nth plant. So this is what we have considered. Plants are located at different locations, isn't it? So PG is the active power generation at mth plant, and PGN is the active power generation at nth plant, and the loss is between these two. So that loss coefficient will be considered as between BAMN. Understood? So that's what I said. This is a general empirical formula. We are representing it here. And obviously, this M will be varying it, isn't it? So M varies from 1 to K number of generators. Obviously, N also varies, isn't it? So many generating plants will be they varying it. So N is equal to 1 to K. So, okay. So that's why we are using it two summation marks, because we have used two indexes here. M is equal to 1 to K, N is equal to 1 to K. So in that way, we have to represent these B coefficients in index form. Okay. So how we got this one, and there is a procedure for this one. So I am aware that is not required for you people. So just to know, should know that how it is represented in index form. Okay. So after representing this one, and obviously any expression, empirical formula or any formula you are representing, you have to represent their terms, what it belongs to. So PGM, PGN are real power generation at M and nth plants. That's what I said. And BMN is your loss coefficients, are also called as B coefficient. That's what I said it. Okay. Now if PGS are in, what is PG? These PGs are, what is the unit of PG, real power generation, in megawatt. So then what is the unit of your loss coefficient or B coefficient will be reciprocal of megawatt. Please remember, If this is in megawatt, then the unit of this B coefficient will be reciprocal of megawatt, that is megawatt inverse. Remember that one, megawatt inverse. Understood? That is the B value we have to consider it. So this is the unit. Now computation of course may be carried out in per unit, isn't it? In any power system analysis, we have seen in last semester what are the advantages of representing the values in per unit. So any computations in power system, those should be carried out in per unit. Understood? So if you want to represent this B value in per unit, B value in per unit, what is the unit of B here now? Megawatt inverse. So this megawatt inverse is multiplied with your base MVA. Understood? So that's how you can convert that one into your per unit values. So here B, the last coefficient will be symmetric matrix. You are going to get a symmetric matrix. Understood? So therefore BMN is equal to BNM. BMN is equal to BNM. So this you have to remember this one. This B coefficient matrix B coefficient is BMN is equal to BNM. So with this one, now let us see here. Okay, fine. I'll remove it. In the meeting. Okay, I cleared it. Fine. Now what we have to do from this equation? This is the thing we got. So why we have taken PL? We had to find out incremental transmission loss. Please remember that one, incremental transmission loss. This is what we are focusing it in today's class. So before focusing that increment transmission loss, so what is the incremental transmission loss is equal to dou PL by dou PGI, dou PL by dou PGI. So what is PL equation? Is this equation. This is the equation. Now we have to take it this one, dou PL, take the partial derivative of this equation with respect to PGI. Understood? So that's what we are doing it here. Now when we are taking partial derivative of this equation 10, so this is what we are going to get. Dou PL to dou PGI is equal to dou PGI of the equation which we have derived, which we have written it. That is equation 10. This is your equation 10. So incremental transmission loss is equal to dou PL by dou PGI, that is equal to dou PGI of PL. What is PL we have defined? This is the PL, we have defined it. Understood? So now you take the partial derivative with respect to PGI. So with PGI, if you are taking it, now this is the resultant equation you are going to get. So before taking the partial derivative, so what you have to do, split this one into three terms here. How you got these three terms? How you got these three terms? So before taking the partial derivative, because it is a double summation is there, so we have to split this one individually. Then we can take individual elements derivative. So how to split? So that means when m is equal to I, n is equal to I. M is equal to I, n is equal to I. So what you are going to get? PGI, understood, into BII into PGI, isn't it? This is the term. So this is the term, I have written it here. Okay. When m is equal to n is equal to I, so this is the term. So when we are removing it ith plant from this summation, then how the equation to be represented here? M is not equal to I here, and here n is not equal to I here, isn't it? Because ith plant we have removed. So m is equal to 1 to k includes ith plant. N is equal to 1 to k includes your ith plant. So ith plant, because we are dealing it with ith plant, so that ith plant equation we have separated here from this one. Whenever you are separating it, one more step you can write it intermediate, and this summation will becomes m is equal to 1 to k, but m is not equal to I, and n is equal to 1 to k, but n is not equal to I, isn't it? So that equation plus this one you are going to get. But further, what you are going to do again here, this is the terms we are getting it. So how these two terms, so we have divided, or we have to split that one. So therefore here you can see m is equal to I and n is equal to I. When n is equal to, when n alone is equal to I, when n is equal to I, so what you are going to get, you are going to get only this summation mark with m constraints. You see, be careful, this n is equal, n, this is inner summation. So first inner summation you have to vary, then outer summation values you have to vary from 1 to k. So when the inner summation value n is equal to I, n is equal to I, understood? Still outer summation will be there as it is. Outer summation will be there as it is. But n is equal to I, what it becomes? PGI, understood? Then BMI, sorry, PGM, BMI, PGI. That means n is equal to I, isn't it? So that means this one, n is equal to I. So only for one element we are taking it, n is equal to I, but this outer summation will be there. So it will become PGM, BMI, PGI. Similarly, this term, how we are going to get, can anyone tell with these things? Can anyone tell how we got this term? How we got this term? Can anyone tell? I told this one. So when both m is equal to n is equal to I, we are splitting that one and we are getting this term. When n is equal to I, we got this term. Then this one, how? Sakshama is given m is equal to I. Okay, good. That is the answer. So when m is equal to I, you are going to get. Understood? So when m is equal to I, that means the outer summation, you are taking m is equal to I. That means only for ith plant you are considering outer. But inner plant varies from n is equal to 1 to k. That one we are taking it here. So that means here when m is equal to I, so this is the term you are going to get. However, you see the difference here. We are represented here n is not equal to I, m is not equal to I. Because when m is equal to n is equal to I, we have taken a separate term outside the summation. Individual term we have taken it here. Understood? So this is the thing. So no textbooks, none of the textbooks will give you this explanation. Please be careful here. Remember this one, understand this step here. How we have divided this summation into this one. So only thing is m is equal to n is equal to I, one term you are going to get. When n is equal to I, you are going to get this term. When m is equal to I, you are going to get this term. So this one and this one, it is one and the same. Only thing is we have divided the terms for a particular ith plant. For a particular ith plant, we have taken it. And only the difference is here n is not equal to I, m is not equal to I when you refer to the limits here. Clear? So after splitting the terms from this one, now you take, because only one summation is there. So now you take partial derivative of this one with respect to PGI. That means only when ith plant, for ith plant here, ith plant we have taken it outside, isn't it? So for this one it remains PGI. So you take the partial derivative. So okay, this is the partial derivative. Okay, one term we are missing it. Now you see here. Wait. Okay. In the above explanation, the other terms are independent of PGI. So therefore, partial derivative of other terms will leads to 0. So that's why we have to neglect the other terms. So only the terms which are dependent on PGI we have to consider. So that's why we have taken only those terms. Other terms are independent of PGI. Therefore, it yields partial derivative of those terms will leads 0. So therefore, you have to neglect it. Now you take partial derivative of this one. Now you see PGI, BII, PGI. That means this is PGI square into BII, isn't it? PGI square into BII. So when you take derivative of that one, you will get 2 PGI into BII. You see here, This is the term. This is a term for this one. Clear? So now next, coming back to this one, you take the partial derivative of this one with respect to PGI. With respect to PGI, that is, this becomes 1. What is left out? BIN, PGN with the same limits. Then this term with respect to PGI. So this becomes PGI is 1. So PGM, BMI. PGM, BMI. The limits as it is, you write it. So that partial derivative, it will become easy when you split the terms and neglecting the terms which are not dependent on PGI, because derivatives will be 0. So this is how we are going to get this one, partial derivative, after taking this one. Hope you have followed this one. Any doubts till this point? Any doubts till this point before moving on? Okay, I think you don't have anything. Now we will rearrange these terms here. So this is m is equal to 1. You see m is equal to 1, b1i, pg1, this term, isn't it? Here in this case, m is equal to 1 for one plant, that is for first plant. So what it becomes? b1i into pg1, isn't it? This term at first plant m is equal to 1, what this term becomes? b1i pg1. Clear? This term. And this term, you see, at n is equal to 1, at n is equal to 1, at n is equal to 1, what it becomes? bi1 pg1, isn't it? Now you see these two terms, see these two terms. This is when m is equal to 1, this is n is equal to 1, you are getting these two. Now what is bi1 is equal to b1i? It is same, isn't it? So I said it is a symmetric, bmn is equal to bnm, isn't it? So therefore bi1 is equal to b1i, isn't it? That means what? This m is equal to 1, n is equal to 1, these two are same, that is pg1 bi1 pg1. So that means these two terms I can write it as 2 times bi1 pg1, 2 times, isn't it? So like that I can write it. Now you see here, this is the term you are getting it, like 2 bii pgi, these two terms. This is when m is equal to 1, so this term becomes this one. This is when n is equal to 1, this term becomes this one, and bi1 is equal to b1i. So therefore here this is also bi1 pg1, and this is also bi1 pg1, so that I can write it as bi1 is equal to b1i. So I can write it like this, isn't it? So therefore that is equal to, so with the new limit m is equal to n is equal to j, a new term we are getting it. Instead of m and n, we are getting a new term. Why new term? Here when j is equal to 1, j is equal to 2, 3, etc. So that's why I have written it here j. Clear? Bij into pgj. So this is what I have written it here. Hope you understood this term. How you got this term? Only thing is, at first plant when j is equal to 1, this is a term. When j is equal to 2, because m is equal to n is equal to j, that means here this becomes j, this also becomes j. New term we are taking it, nothing else here, no difference here. So that's what this, all this micro level explanation is not available in the textbooks. So that's why I'm taking more time to you to explain this one. Hope you understood this one. Any doubts how we got this term? So similarly, when m is equal to 2, n is equal to 2. So we'll get pg2, pg2 with b12, so, and sorry, b2i and bi2 we are going to get, isn't it? So therefore, here this is symmetric, these two are equal, this is pg2, pg2, so 2 times of that one. So like that you keep on adding all the terms for each value of m and n. So that's why adding summation with the new limit is equal to j is equal to 1 to k, where j is not equal to I. Because why? When j is equal to I, we have separated the term already from here. So this can be written as bij into pgj. Any doubts till this point? Hope you understood this term. How you got this term here? Understood? So if you want, you can analyze it, take a paper. When n is equal to 1, m is equal to 1, write a equation and you can write it that one. One term you are going to get. That is, what is that one you are going to get? So bi1, 2 times of bi1 into pg1. When m is equal to 2, n is equal to 2. So what is the term you are going to get? 2 times bi2 pg2 you will get. Isn't it? When m is equal to 3, n is equal to 3, what is the term you are going to get? Plus, we have to add, keep on adding it. So what you are going to get? bi3 pg3. So like that you will be getting it summation. So all those summing terms I am representing it, because m and n are each time it is varying simultaneously 1, 2, 3, etc. So I am taking a new limits with m is equal to n is equal to j. So j is equal to 1 to, so then bij pgj, it is multiplied by 2, because every time we are getting 2 times of this equation. Hope I would have shown it that equation here before deriving this one. You would have understood in better way, but you do it on a paper. Just you split this term. When n is equal to 1, what is this term? Okay. When m is equal to 1, what is this term? This you do it. So you will get a 2 times of bi2 and pg1. Similarly, plus m is equal to 2, n is equal to 2. You write the terms. This one plus this one. So again it will become 2 times bi2 pg2. Like that you write some 3, 4, etc. Then you will understand those summation will be represented in this form with a new limit j is equal to 1 to k. You take a paper and try that step, intermediate step, you will get it. Is it clear? Hope you understood this point here. Because this, whatever red arrows I have shown, these explanations are not available in the textbook. So that's why with the clear indication I have explained it. Hope you have understood this one. So same thing I have written it here. Now here you see, this is the equation. Now I want to bring this term inside this one, inside this summation. So this is the term for ith plant, isn't it? You see this term and this term, it is BP. It is a product of B and P, isn't it? So here also it is a product of B and P, isn't it? Multiplied with 2. Product of B and P multiplied with 2. So this term and this term is similar. So I want to bring this one inside this one. Then what happens? This is a term when the plant is equal to ith plant. So therefore, when I bring this one inside, so what happens? This j is equal to 1 to k also includes ith plant. So therefore, in such case, you can remove j is not equal to I. Understood? Hope you understood this point. Now I am trying to bring this ith plant term inside this term. So whenever I am bringing this one, why I am bringing? Because it is same. This one and this one is same. So whenever I am trying to bring in within this summation, so this term includes ith plant term also. So therefore, j it includes ith also. So remove this, j is not equal to I. That's what I have done it here. You see here, now j is not equal to I is not included. So that means this term also includes ith plant term. Hope you understood this step. So how to remove a corresponding plant term from the summation, and how to include a particular plant equation into the summation. Already we have seen this one in Gauss-Seidel method, Newton-Raphson method, etc. So here also we are doing it. That is a simple mathematics there. Now this is already I have repeated. Consider a quadratic plant cost curve. Ci of Pj is equal to half Ai Pj square plus Bi Pj plus Di. Nothing new here. Already I have explained this cost curve. Now you have to take derivative of this one. dCi by dPgi is equal to what? Ai Pj plus Bi, isn't it? with respect to PGI. So this becomes BI, this is 0, and this becomes 2AI PGI, 2 gets cancelled, so left out will be AI PGI plus PI. Call that as equation A. This is nothing new here, already we have done this one. So just for your understanding, again I am repeating it. So I am calling it as a A here. So what is this DCA by DPGI? It is an incremental fuel cost of your ith plant. Incremental fuel cost of ith plant, and the unit of this incremental fuel cost will be rupees per megawatt hour. And what is the unit of this cost? Rupees per hour. Please remember these units. What is the unit of B coefficient? Megawatt inverse. Clear? So now after getting this one, now substituting this A in 9. What is equation 9? This is the equation 9. Understood? So just because this is a presentation, I am repeating that equation again here. Otherwise, no need to repeat this equation. So this is your equation 9, which we have derived, is known as, what is this equation known as? What is this equation is known as? Can anyone tell? What is this equation known as? This one. Okay, I got the answer already from Saksham Sharma. Others, what is this equation known as? Sushumna has given. So that's what I repeated several times. You should remember, otherwise you will commit a mistake in the test examination or in your competitive exams. Those who are trying for your PSUs, GATE exams or any other competitive exams, you should know these small things. These basics are very important. This is known as, both of them, Saksham and Sushumna has given the right answer. It is exact coordination equation. This is exact coordination equation. So in this exact coordination equation, so substitute this A. What is this DCI by DPGI? Is nothing but incremental fuel cost. So incremental fuel cost is represented by IC, isn't it? Same thing. This IC is nothing but this one, DCI by DPGI. So substitute this one here. So A we have to substitute it. Now you see, this is IC means it is incremental cost. What is the incremental cost? This one. AI PJ plus BI is equal to lambda into 1 minus, what is incremental transmission loss? What is the incremental transmission loss? Is nothing but your dou PL by dou PGI. This one. Just now we got it. So that you substitute here. 1 minus of this term. 1 minus of that term you substitute it here. Understood? Hope you understood this one. Just substituting that one in coordination equation. Now again, once again, what I am doing it. So instead of doing it 2-3 times, you can use this equation itself directly. This equation already we have done, isn't it? From here, this is only you can substitute it. The ITL, you can substitute it, this equation. Again, see here, that equation I substituted minus, isn't it? So minus ITL means minus of those two terms. So what here I have done, I have taken ith plant also inside. Okay, substituted. Again, I am taking ith plant outside. So why to do it? So directly you can substitute the previous equation itself here. This one. This is your ITL, incremental transmission loss at ith plant. This equation only you can substitute it here directly. So you can skip this step. Understood? You can skip this step. So directly you can substitute that one here. Now I want to take all PGI terms on one side. Taking PGI terms, you see here AI PGI plus BI, I have taken it on RHS side. This BI, I have taken it on RHS side. So becomes minus BI. And here you see, what is this term? What is this term? 2 lambda is there. 2 lambda BII PGI with negative sign. I am taking that one onto the LHS side. So becomes this one. Because I want to solve for PGI. So I am taking PGI terms on one side. That's what I am doing it. So this BI, I have taken it on RHS side, and this term multiplied with lambda. I've taken term LHSI. Now PGI is common here. Take it out, PGI outside. Okay, left out will be AI plus 2 lambda BII is equal to the same equation on RHS side. And therefore PGI is equal to, this is the equation where I is varied from 1 to 3 K etc. is equal to plants. Understood? Here it is plants. I is equal to 1, 2, 3 are plants. Whereas neglecting transmission losses, it is called as I is equal to 1, 2, 3 etc. K are called as units. That is the difference. Their units, here it is plants. So this is the equation you are getting it PGI. So whenever they ask derive the expression for PGI or active power generation considering transmission losses. So till this point you have to do starting from yesterday's class. They may ask for 10 marks. So then this whole thing you have to do it. Some 5-6 marks they will ask only till this point. So extension is you have to find out ITL, get this equation, substitute it, then rearrange the term, solve for PGI, you will get this equation. Clear? In some textbooks, what they will do, they will take this lambda outside. So this becomes AI by lambda plus 2 BII. Lambda is there, no? So when you are taking it here, so further they will do some simplification here. If you want to do, you can do it, otherwise not required. You can keep it like this only. That is only the difference. Now here, these are the limits. It is not showing properly. Here, this one should come here. J is equal to 1 to K. It is understood like these limits. Should come J is equal here. This one J is equal to 1 to K into Bij into Pgj. Summation. So this is your PGI. Hope you understood this one till this point. Any doubts till this point? Okay. Hope. So this is the derivation, you have to do it. Now equation 10. What is equation 10? What is equation 10? I will show you. This is your equation 10. Isn't it? What we have done, the B coefficients can be represented in different forms. Before, just on the starting of this class, I told this B coefficients can be represented in different form. So we have represented in index form, that is M is equal to 1 to K, N is equal to 1 to K are your index. So index form are also represented, can also be represented as in matrix form. That is another way. See here, can also be represented in matrix form. This is the other way. This is for numerical problems, it may be helpful. How it is represented PL? We have seen that index form 2 with 2 summation, we have shown it. And we got this one. Different methods are available. Sorry. So how it is represented? PG transpose into B into PG. PG is active power generation, B is your loss coefficient. Understood? This is the other form of representing your transmission loss. First one is index form. The second one, it can also be represented in matrix form. What is PG is equal to your PG1, PG2, etc. PGK. Understood? So there are K number of plants are there. What is your B? It is a symmetric matrix. Understood? It is a symmetric matrix. B11, B12, etc. B. They are assuming there are K plants. And how to write first row, you know it. For second plant, it is B21, B22, B2K. For third plant, etc. For kth plant, it is BK, BK2, BK3, etc. BKK. And where B21 is equal to B12, it is a symmetric matrix. This is how the B matrix will be represented in matrix form. Is it clear? PG transpose into B into PG, where PG is this one and where B is this one. So when you substitute that one and expand, you will get a equation. If you consider 2 plants, you will get a second order equation. If you consider 3 plants, then you will get a third order equation. If you consider 4 plants, you will get a fourth order, etc. How we are going to get? If it is a two plants, consider Pg is equal to Pg1, Pg2. So then what is B? Only this much. B11, B12, B21, B22. 2 cross 2. If it is 3 cross 3, 3 plants are there, then Pg1, Pg2, Pg3. Then B will be B11, B12, B13. 3 cross 3 will get B21, B22, B23. Understood? The third row will be B31, B32, B33. 3 cross 3 you are going to get, depending on number of plants. So let us consider, so I said this one, for 3 plant system we can write the expression for loss. For 3 plants, so using this matrix form, how we can write? This is the equation you are going to get. So you can say, write it, Pg transpose means Pg1, Pg2, Pg3, row wise, because it is a transpose. So we are, sorry, Pg1, Pg2, Pg3 you can write. B is 3 cross 3 matrix, you write it in this fashion. Then what is Pg? It is a column vector, Pg1, Pg2, Pg3. Simplify those one. So you will get this equation, B11 square Pg1, B22 Pg2 square, plus B33 Pg3 square, plus 2 times B12. Why it is we are getting 2 times? Because B12 is equal to 2, 1, we are going to get another term. Into Pg1, Pg2, 1, 2, then 2, 3, 2, B2, 3, then 3, 1. If it is 2 plants, what you are going to get? B11 Pg1 square, then B22 Pg2 square, plus this term 2B12 Pg12. These two and this term you are going to get if it is a 2 plants. How we are going to get this one? Just to substitute these values and solve those matrices. So you will get this equation, transmission loss. Please remember this one. This is required in matrix form for our future studies. Okay. So this is the thing you should remember it. So in today's class, we have derived the equation for active power generation considering the transmission losses. Understood. So these transmission losses are represented as B coefficients, and this B coefficients, so this transmission losses can be represented in different forms. One is index form, and when it is represented in index form, we have seen we got PGI equation, final equation, can also be represented in matrix form, which is there on your screen. This way also you can solve your PL. So once after getting PL equation, take partial derivative of this PL with respect to PGI. So whatever the resultant equation will be your ITL, incremental transmission loss. Substitute this one in your equation 9. So you will get the required equation of PGI. This is what we are studying in today's class. So any doubts till this point? One is index form, the other one is matrix form. We have seen it. Any doubts? No doubts, then I am going to end the class. Okay, thank you very much. Take care. Bye.